Hi guys, in this video we're going to go through an example of how to use Simpson's rule to approximate the area under a curve using the graphics calculator. So Simpson's rule is a rule that comes up in Specialist. It's kind of same but different to the trapezoidal rule in a lot of ways. The only difference is that you'll notice that there's a coefficient of 4 in front of x1, x3, x5, etc. So all of the odd values. And there's a coefficient of 2 in front of x2, x4, etc. for all of the even values. Similar to the trapezoidal rule, the value at the front here, the first term has no coefficient, and the last value also has no coefficient. Okay, so let's jump straight into this question. So it says use Simpson's rule to approximate the area under the curve of f of x is equal to ln of x between x equals 1 and x equals 2 with 4 sub-intervals. Okay. So the width in this case is the width of each sub-interval. So if we had to split the area between x equals 1 and x equals 2 up into 4 sub-intervals, how that would kind of look is we'd have, well, 1's always going to be our x of 0. The next term's going to be 1.25 for x1. Then we're going to have 1.5 for x2. Then we're going to have 1.75 for x3, and then our final term on the end is just going to be 2, which is the end of the interval. So you might be thinking, well, hang on, isn't this 5 intervals? But no, it's not, because the distance between each of these is considered one interval. So essentially the distance between here and here is 1, the distance between here and here is 1, the distance between there and there is 1, and the distance between here and here is 1. So we've got 5 values, but we've got 4 sub-intervals. We've got 4 little areas underneath this curve. There is a very unlikely chance that any sort of question like this is going to ever be in a Tech 3 exam. If it does show up in an exam, it's going to be in the Tech Active section. Therefore, it's important to know how to use your graphics calculator most effectively to answer a question like this in the least amount of time. So the first thing we need to do is we need to define f of x. So I could say f of x is going to be defined as, we can click Control and hit this button to define a function, and then we're going to write ln of x. Now, the long way to do this question would be to go and do f of 1, and then f of 1.25, and then f of 1.5, etc., and then go and substitute all of these back into the formula. Instead of doing that, realistically, we can just do all of this, all of Simpson's rule, in one single line. So when we're figuring out what the width of each sub-interval is, the width of each of these sub-intervals we can clearly see is going to be 0.25, which is the same as 1/4. So if we do 1/4 divided by 3, that's the same as 1/12. So this front fraction here, when I enter that into the calculator, it's going to be 1/12. Now it's just a matter of going and substituting everything that I need to into this formula. So my first term is going to be f of 1, which does not have a coefficient in front of it. Then I'm going to have a 4 in front of f of 1.25, because that's x1. Then the next term I'm going to alternate, so I'm going to have a 2 in front of this term here, etc. So the next term I'm going to have a 4 in front of f of 1.75, and then we're going to add on just the last term, which is f of 2, close bracket. So when I hit enter, this is going to give us an approximation of the area under the curve between x equals 1 and x equals 2 for f of x is equal to ln of x. So that's the value we get. We get 0.38625. Let's actually now just find out what the actual integral would be. So a quick way to do that is we can just click on this symbol here. There's a bunch of options for us. We want to do an integral with intervals. And we just want to go 1 to 2 of, we can just write f of x here because we've defined f of x with respect to x. Okay, that's given us an exact value. There we go, pretty close approximation. That's it for this video, guys. Thanks for watching.